Now let's talk about the section 3, the graphs of the sine and cosine functions. So from now on, we use the x as the independent variable instead of alpha. So we talk about the y equal to sine of x, or just write the sine x. Okay. And to draw the graph of the sine function, we first compute the 5 key points on the graph. So you have the 5 key points. On the graph. So we take this 5 values of x and then get the y equal to sine x. First, let's take the 0. Well, sine 0 is equal to 0, right? Then let's take the half pi. What is sine of half pi? 1, right? Then sine of pi equal to what? 0, right? 0. Okay. Then 3 pi over 2, 1 or negative 1? Negative 1, right? It's in the, okay, it's below the x-axis. So this guy is equal to negative 1. And then 2 pi. So 0 again, right? 0 again. Now let's look at this fig 5.37 on the page 447. So now this is your angle x, right? And as the x increases, first we are here, right? So the sine of x is equal to 0. Then as x increases from the 0 to half pi, so right here you get half pi, then you know the y value of this point, sine x, just increases from the 0 to 1, right? You see this y value increases from the 0 to 1. If you move this point from here to here, then the corresponding angles, okay, the corresponding angle just changes from the 0 to half pi. So from the 0 to half pi, sine x increases from 0 to 1. Now, from the half pi to pi, so when you move to this point, you get the angle pi, right? So right now, from half pi to pi, then this time you see this y value just decreases from the 1 to 0, right? And then from pi to 3 pi over 2, the sine of x continue to decreases from the 0 to negative 1. And from the 3 pi over 2, so this point corresponding to the angle 3 pi over 2, from 3 pi over 2 to 2 pi, then this time sine x increases from negative 1 to 0. So this is how sine x changes with the input x. Now we can draw these 5 key points. We get the 5 key points. Let's get the order pairs for them. 0, 0, half pi 1 pi 0 3 pi over 2 negative 1 and 2 pi 0. So first we draw these 5 points on the rectangular plane. Zero, 0 here, and this is the half pi. So half pi 1 is about here, and then pi 0 here, and then 3 pi over 2 negative 1. So this is the 3 pi over 2. So negative 1 here, and then 2 pi 0 here. And we just seen sine x increases from the 0 to half pi. So you can have the curve like this. And decreases from half pi to pi. So you have the graph like this. And then continue to decreases from the pi to 3 pi over 2. And then increases from 3 pi over 2 to 2 pi. So now, in this way, we get the one cycle of the sine function actually of x is in this closed interval from 0 to 2 pi. And this interval is called the fundamental cycle of the sine x. So this guy is the fundamental cycle of sine x. Let's go back to this figure. We know x and x plus 2 pi or plus 2k pi just have the same initial side and the same terminal side, right? So that means you have the sine of x plus 2 pi equal to sine x, right? Because x plus 2 pi and x have the same terminal side, then you have the same point of intersection, same y value. So sine of x plus 2 pi equals sine x. So actually when we see sine of the x plus 2k pi equals sine x. So now we just draw the fundamental cycle of sine x from the 0 to 2 pi, and since sine of x is equal to sine of x plus 2k pi, so the graph of sine x just repeats itself infinitely times for every interval of the length of 2 pi. So you see here from negative 2 pi to 0, you have the same shape, right? And from 2 pi to 4 pi, you also have the same shape. So this guy just repeats itself infinitely many times. And this looks like a wave. So actually we just call the graph of sine function a sine wave, or the sinusoidal wave, or the sinusoid. Okay, so this is the graph of the sine function. And from this graph you can also see the maximum of the sine function is equal to 1. See here, and the minimum is equal to negative 1, right?